Hey, Honors Calc, just want to finish up that problem we started in class and ran out of time on. So remember we used this idea of similar triangles. We know that the ratio of this little triangle for the man with the shadow has to be equal to the whole thing. So we said, well, also 19 to 6 has to equal this whole thing to this. So D plus S to S. So what I thought was here, I could do the quotient rule and differentiate. This would be 0. I don't know if this is actually going to make it easier, but I'm going to multiply my S over. And then let me differentiate with respect to T. I'm not sure if it'll make it easier. I have an inkling it will. So let me now take the derivative with respect to T on both sides. I probably should have left a bit more space. Slide that over. Okay. Oh my gosh, silly. What did I do? I forgot to get rid of the S on this side. So this is just D plus S. My apologies. Okay, so this is just a constant, so I'll just get 19 over 6 ds dt equals dd dt plus ds dt, because for our sum I just take the derivative of each term. Okay, we know the dd dt, or basically this distance, is changing at a rate of 5 feet per second, and we want to find ds dt when d is 24 feet. I guess we didn't really have to find this, it turns out. Right, we did all that work to find that. Alright, well, let's keep going. So, ds 19.6 ds dt, well, let me get my ds dt's together, so I'll subtract 1 ds dt from both sides. That'll cancel there, and I'll get minus 1 is like minus 6, so that'll be 13.6 ds dt equals, well, we know dd dt we said was 5, so that equals 5, multiplied by the reciprocal, which would be times 6/13, and I get ds dt equals 30, 30/13. So that was the how is the shadow changing. So as this person is walking this way at a rate of 5 feet per second, the shadow is growing at a rate of 30/13 feet per second. And if I go to the Drexel website, which I think I must have pressed the button to automatically pause it, but yeah, we had the correct answer. So if we look here at this diagram, as you walk this way at 5 feet per second, this is changing at between 2 and 3 feet per second. Interesting. That's how much your shadow is growing at that exact instant where that distance is 24 feet. Okay, well, tomorrow I'll post something for everybody to take a look at, but I wanted to wrap that problem up we started in class, and then I'll be sure to post a video with some instruction for tomorrow. It's a full class period. We got asynchronous, so hopefully we can have a little bit of learning, and hope you all have a nice rest of your day. Much love, everybody.